Number 2 gives us a square and asks us to find the net force on the charge that's at the center of the square. I'm going to consider all the forces acting on this. We have an attractive force from this corner. I'm going to call that F1. We have an attractive force from that corner, an attractive force from that corner, and a repulsive force from that corner. Some things that'll simplify this problem. F1 and F3 are going to be the same magnitude because my charges are the same and my distance is the same. And they're in perfectly opposite directions. So F1 and F3 will cancel, leaving me F2 and F4. F2 and F4 are going to be the same magnitude. The same magnitude because they're both between a charge of 2 and 4, and they're both the same distance apart. So if I find one of those, I then know both of them. They're going to go in the same direction, allowing me to add the two. So what I need to find here is I need this distance. So I'm going to look at the fact that I know it's a square. If I cut my square in half like this, at 0.6 on the side and 0.6 on the side, I have a 45, 45, 90, meaning my hypotenuse will be 0.6 rad 2. .6 rad 2 gives me 0.849 meters. But I'm going to want just half of that distance because I'm going from the center over. So 0.849 divided by 2 makes this an R equal to 0.424 meters. Now solving for my force. The force between the 2 and the 4, using Coulomb's law, 9 times 10 to the 9th. My charges are in microcoulombs, and I need to put them into coulombs. 2 times 10 to the negative 6th. 4 times 10 to the negative 6th. The distance between them is 0.424 squared. Solving for the force, I get a magnitude of 0.4 newtons. That is force 2, and it's also force 4. So I have 0.4 newtons, 0.4 newtons going in the same direction. They're going to add up, giving me 0.8 newtons at a 45-degree angle, and we're going to label this north of east.